So thank you all for coming. Have a nice and warm welcome here at IEV. You are in the digital lab of IEV, and the digital lab is all around innovation and in the recent future also AI developments, because that's one of the hottest topics which we currently have in the automotive industry. And thank you all for the nice introduction and for coming. And I will talk a little bit about driving the future, how AI is powering the automotive revolution. If we talk about AI and the automotive industry, most people automatically think about something like self-driving car or AI-based sensory technology or stuff like that. But here at IEV, we are faced with different kind of challenges. Because if we look at the engineering process, it is not about mechanical engineering or electrical engineering. It's all about, or mostly around, requirements. And when we talk about requirements, we usually are confronted with a lot of them. A usual car here, which you have in Germany, has around 500,000 requirements, and they are in textual form. And what you can see here is basically that all of these requirements have to be somewhat fulfilled for a customer, for a big automotive company like Volkswagen, but also needs to be ready and tested that the requirement is actually fulfilled. And because this is such a huge burden of having so many requirements for a single vehicle, the automotive industry has come up with a process which is called SPICE. SPICE is a little bit related to the V model. Many of you might heard about that. So you have different levels of kind of how detailed you specified something. So for example, we have the SIS level, we have the system engineering level, so the highest level. So you look at the car, what needs to have, what kind of stuff a car needs. For example, 4 wheels, a motor, an engine, whatever. And then you go down in this V, and you also have sub-Vs. So for example, domain levels like software, machine learning, hardware levels. And all of these are connected together and have different levels of complexities and different levels of abstractions. And what you see then here is that you have these kind of levels which you all need to fulfill, and all are somewhat connected to each other. And that basically means that completing the requirements in high quality is basically the duty, and the goal is basically by verifying that these requirements are actually fulfilled in the product we finally make. And what we see in recent years, and that is something which is a mindset shift in the latest years. And if you develop software, you might remember or have seen this kind of infinity loop, which is probably quite common in modern software engineering, like continuous integration, continuous development, stuff like that. But in the automotive industry, this kind of processes are not so well integrated into the current developments. But this mindset shift is currently happening. And this mindset shift is actually made possible by AI, because we have this crazy complicated systems with 500,000 requirements and so on. That means that if we want to do this infinity loop with continuously improving and continuously developing these kind of products, we need to find tools to somewhat organize the complexity of these systems. And this is something which we do here at the Tech Hub. We accelerate the engineering by integrating AI tools into the engineering process. This map here shows a little bit what we are currently working on. So we have different kind of AI products. We have, for example, for requirements engineering, so really in the textual descriptions of what's going on there. We have, of course, not only the requirements, but somebody has to actually develop the software which are basically described by the requirements. We have a lot of norms, we have a lot of rules, and a lot of legal obligations which we need to follow. Therefore, we have something like InVistonBot, which is basically a RAG system. We have, of course, also for testing all of that which we have engineered in our requirements. And we have a lot of stuff which is basically subsidiarity to this whole textual description of what's going on, which is basically Mela or Meridia, which basically generates scenarios for virtual development. Because this is something which is also kind of an upcoming field, software-defined vehicle and virtualization, to make faster test and development cycles possible. To put some numbers here, we have a lot of, most of these tools are actually already rolled out productively. So we're working quite hard the last 2 years to make this possible. So for example, we have the dependent requirements, which I will have demos for all of this, but basically we have within IOB 500 active users and a lot of requests. We have AI tools for software development, which is basically mostly quite near to the hardware, so embedded software development, for example. We have our RAG system for our legal and our company knowledge, and a lot of other tools, for example, the testing to generate the test specification needed to verify that we have already implemented a certain development requirement. And to give a short glimpse of how we did this, I've put together a slide which shows what we actually use underneath. If you are developing software or an AI engineer, you probably know some of these logos. I think it's nowadays more or less common that some kind of open source repository have a nice logo on their hand. So for example, we use Qdrant, we use LangChain, AutoGen, AG2, Fast API, and a lot of stuff. So most of them are evolving around Python and web technologies. And that's how these tools are built nowadays at IAV. If you're wondering what is IAV exactly, I have never heard about that. You're probably not alone. I haven't heard about IAV. I haven't heard about it at the first time I've started working at. And it's kind of a large company in the automotive sector. We have almost 40 years of experience now in the field. We are more than 6,000 employees with 25 locations worldwide. So we have kind of settled in this field. We have a lot of engineers, we have a lot of software specialists, but also what is coming quite fast in the recent days and years is our capacity of creating AI products. Yes. And just to give you a glimpse of who our customers are, we are basically most of the time in the automotive industry, so we have the well-known logos. We have Audi, BMW, Bosch, Volkswagen, and so on. And that's basically what IAV is here all about. And before I start to present how these tools actually work and how they look like, my question is here anybody who does not know what a large language model is? Yes? No? No? Okay. So nowadays we have this problem, what is actually AI? And AI is probably a buzzword for basically everything which happens in the field. Makes it really hard to distinguish what's actually going on. And for us, artificial intelligence is basically creating machines and software that mimics aspects of human intelligence. So for example, we generate text, we chat with these systems, we generate pictures with it, or code, or whatever kind of stuff. And this is basically just one aspect of it, because artificial intelligence also involves around machine learning and all of these technologies. So to specify a little bit better, we would go into this generative AI cycle, which basically arounds in I have an input, it can be text, it can be video, it can be images, and also you output something like this. And sorry. Yeah. And that's basically Gen AI, which can also round creating images from images. So we are not in this language kind of field. But if you want to do that, we would go into the domain of large language models, which is actually specialized on generating text. And this text is basically, these models are basically used to do this, what we now call ChatGPT. So basically, the rise of ChatGPT is based on the foundation of large language models and the training of these. And what makes large language models so special, and especially ChatGPT, is that they are trained to mimic our behavior, or to put it a little bit more into technical terms, they are optimized for our preferences. So if you try to write a poem, try to write a kind of piece of software, they are basically optimized to exactly do that. And it works like that. You basically use the whole corpus of the internet, all books you can find, all blog posts, all software codes which you have, and then you forward it through the neural network, which is basically the foundation of the large language model, and then you decide that you want to use to predict the next word. Here in this example it would be the Eiffel Tower is, and the result would be, in most of the cases it would be in, and here again in most of the cases it would be Paris. And that's how these models are trained. They are trained to optimize or to predict the most probable word in most scenarios. And this generalizes to basically also to techniques like ChatGPT or others, which are basically then are optimized. The next possible word or the most probable word is a word which would help you as a user. And because they optimize to follow what you want, or to mimic the behavior of what you want to achieve, you can do a lot of stuff with that. For example, a technology which we know all probably, which is called prompting. And this prompting is basically the foundation of most of the technologies we use, which you will see in the next few slides. For example, if you imagine, so what is requirements? And requirement is a textual representation of what a system should have. So a car should have 4 wheels, for example. A car should have an engine. So all of these, they can be arbitrarily complex and arbitrarily bad. And that's a real problem if you have 500,000 requirements. That means that one of our assistance tools is basically assisting the requirement engineering process. And before doing anything fancy, just check, is the quality sufficient for further steps? So for example, does it follow a certain language? Is it technically feasible? Is it in some way complete? So for example, if you want to specify something and it's unclear if the requirement is somewhat complete, you get into problems. If you do that, you get a list of yes and no's, which is basically then describing what you have as an input. And one type of solution which we can offer here is basically that we make auto-correction of the requirements and that we make consistency checks on these whole text blocks. And basically also generate further into going down in the V. We talked about it, right? We have different levels of V and we go down in the V. And if that sounds a little bit abstract, I have an example for you. So what we see here is basically that we have a list of requirements on the left side. The vehicle attendant must have the ability to monitor the status of the shuttle. I'm currently not sure what the problem with this requirement is, but what we see here is that we have an AI system which is prompted to inspect the specifica of this kind of requirement and then tells us if the requirement matches what we specified in the forehand. And what we have seen here is also that we have some types of requirements, for example the later one here. And what we see here is basically that the AI system also suggests us what we should change to match what we actually want to achieve with the requirement system. And that basically brings us to that we can automatically quality check our requirements and autocorrect them. And this is basically a huge benefit which is founded in an NLP pipeline. And to see what's actually going on here, I have a short demo for you with me to demonstrate what's going on. So for example, one of the features is that you can just put a PDF into it. In this term, it's the EU AI Act, which is a PDF file of 144 pages, and then just drag it, drop it into the application. You also specify what you want to have with that. So basically it's an AI software system, as most AI systems are nowadays. They are software systems. And when we click on proceed, we will be guided through this process, and then it will take some time, and then we will see that out of these 144 pages we have actually extracted 26 pages of requirements. And that's basically all of an AI pipeline, which is forwarding the pages through these systems and prompt this AI system to follow certain guidelines and categorize them into requirements, into heading, into functional and non-functional requirements. And that's basically one of our systems here. And we can see here that we have 649 requirements generated. Yes. Yes, if you want to try it out, you can have a demo here. If you can access this via our webpage or our Azure Marketplace, your data will not be used for trading purposes. So if you're interested, give it a try. One of our other features which we talk about often is the types of testing. So if you have half a million requirements, and then you need to verify the whole functionality of that we really have to fulfill everything. That means basically that you make sure that you understand the system at hand. And that's just one of our next tools which I want to present here. It's basically that this Excel sheet which you see here on the top is basically thrown into the system, and what we do here is we use the GraphRag technology to generate schemas and make sure that we generate a knowledge graph out of the provided requirements. We can see here that we can now visualize all of the content and the information which is actually presented here, and you can see here that this knowledge graph is kind of elaborated, and you can search and chat with it. So for example, if we have this requirement for, 4 wheels, it needs to be an engine, then basically these types of questions can be asked to the system. And then of course we can also generate test cases. For example, if I want to test that the car has 4 wheels, I probably have to look that it really has 4 wheels, and that's example. Of course, software engineering is important. And that's one of them, of another supporting tools which we have. So we are in the V. Basically, we are on the left side with requirements engineering. We are on the right side with creating test specification. But at some point, you have to deliver something, which is most of the time is code. And that's the third part of our assisting processes, which is basically an AI bot which writes software for you. In this case, you might have heard that it is continue. We supported a branch for it and have different types of models for it to generate, for example, unit tests, to implement requirements which you have specified autocorrected beforehand. And then you actually want to test these requirements, then you can also use these tools to actually generate the code for the test specs which you have. Yes, and most of you probably will know that. So you know this kind of chat window. You have your GPT-4, Omni, you have your Cloud, you have your Gemini, and then you usually work like that you input something which you want to generate, something like generate and test, please explain the code. But what if this types of interaction is not enough for you? What if you want to have a more sophisticated software? What if you want to make sure that the code which the LLM writes is actually compilable and runnable? And here is something which is the next step of the evolution when it comes to AI and AI-based engineering, which is the elephant in the room, which is multi-agent systems. And these multi-agent systems are basically designed to somewhat autonomous and to have the ability to be independent of the user who used it. And that basically allows us to input a certain task which he wants to achieve, and then say, I have a requirement, please look up the test specification on your own, and then please implement everything on your own, please compile it on your own, and then please give me a final report of what you have achieved. One thing how to do that in IAV is currently with Icarus. It's an IAV code agent which we call for reliable universal automotive solution. And the basic idea is that we use a tool like Icarus to provide users, in our case engineers, with various tools like different kind of agents. So we offer a multitude of agents. In our case, we have automotive agent architects, we have software developments and all of that. And we provide the user with some kind of model context protocols to, for example, access the tools he really wants to do. And of course, we also access or support the user with different HTTP connectors, which is basically another language for using an UI, or the terminal for really being down into software. And that basically means that this kind of system is universal and can be used between any framework. So for example, AutoGen or Llama Index or LangGraph. So you can basically plug in every agent you want to have and basically have it production ready immediately. One example of this is basically our integration tester, which we developed last year with the system. Basically what I want to show here is basically that a user has an initial task and feedback, and the multi-agent system is capable of accessing memory, accessing the databases which he actually wants to have his requirements out of it, and then uses the tools which he have to execute the code, to generate a coverage report, to make the code retrieval, to really verify that, okay, I have tested a certain requirement, and indeed I can make the verification that for this part of the software the coverage report is actually increasing. And that means that we have successfully created this kind of test, and that we have successfully have one test case less to really verify. And because the time is rapidly moving forward, I would basically skip to the end and would open the Q&A session to be in time. So that's basically the last slide. That's the AI suite for which we, also our response to accelerating the automotive industry with AI, the engineering process with AI. And thank you all for listening.